Okay, well, we're continuing with our look at finding trigonometric functions of certain special angles. If you remember in our last problem, last video, we looked at examples where the reference angle was a size 60. So what we were doing was taking this triangle and placing it inside the circle. And we came up with these pink angles, pink terminal sides that you see here. But it turns out we can take that same triangle and turn it over, okay? And by turning it over, we can put the 30 degrees at the vertex, and we end up with the blue angles. So actually the blue ones are ones we're going to be looking at in this video, and those blue terminal sides there, okay, again, naturally it's going to be on a circle of radius 2, but those blue triangles then are going to have, blue terminal sides are going to have reference angles of 30 degrees, or pi over 6 in radians. So let's take a look at those. And so the ones that we want here are right here, and so those are your reference triangles. Now notice the way this is set up. This is your same triangle that we had. Radius is 2 in all the cases. Okay. The longer side is the one that's along the x-axis. So that has radius, or not radius, but that's the length of square root of 3. So your vertical sides then have length 1. So there's your 1, 2, and square root of 3 for your ratio of your sides. The one opposite the 1 is the smaller of the two angles from this special triangle, which is 30 degrees, or pi over 6 in radians. So if we start at the initial side here and spin it this much, just that much, okay, from here to here, then we've gone 30 degrees, or pi over 6 radians. Of course, going this way, we go just pi over 6 short of 2 pi, so that would be 5 pi over 6. No, let me say it again. How about all the way around would be 2 pi, which is 12 pi over 6 negative, but we're short of that by pi over 6. So it's actually going to be negative 11 pi over 6, or positive pi over 6. So in other words, either positive 30 degrees or negative 330 degrees. Or any other rotation that's going to end you up at this same place. So this point here on the axis there, not on the axis, but on that terminal side, has coordinates y is 1, x is square root of 3, and r is 2. And of course, anytime we know x, y, and r, we can use our basic definitions to come up with these trig functions. Cosine is x over r, so it's square root of 3 over 2. Secant is its reciprocal, r over x, so it's 2 over square root of 3. Sine of pi over 6 then is y over r, so that's 1 over 2. Its reciprocal cosecant is r over y, so that's 2 over 1 is 2. Tangent is y over x here, which is 1 over square root of 3, and cotangent is x over y, so it's square root of 3. So I'm going over these each time to remind you every time of those definitions, also to make sure I don't have any typos in this. Okay? What if we go down here in the second quadrant and go minus pi over 6, or if we do it as a positive way, it would be 11 pi over 6. That is 330 degrees would be 11 pi over 6, or negative 30 degrees would be negative pi over 6. Now notice what we have here. An x of square root of 3, a y of negative 1, r of 2, and so we get x over r, square root of 3 over 2 is cosine. Notice cosine is positive for both the first quadrant and the fourth quadrant. Sine, however, is going to be negative down here, because y over r is negative 1 over 2, so it's negative 1/2. Same size as the sine in the first quadrant, absolute value, but negative in sign, negative sign. Okay, cosecant of negative pi over 6 is then its reciprocal negative 2. Tangent is negative 1 over square root of 3, and cotangent is minus square root of 3. If we rotate around to the second quadrant, so that would be pi minus pi over 6, that's 5 pi over 6, or let's see, 180 minus 30 would be 150 degrees. We did degrees. And so there it is at 5 pi over 6 would be the shortest rotation, which is positive rotation. X is negative square root of 3, y is 1, and r is 2. And so, of course, cosine being x over r is negative square root of 3 over 2. Its reciprocal is secant, which is negative 2 over square root of 3. Sine is y over r, that's a half. Its cosecant is the reciprocal, which is 2. Tangent is negative 1 over square root of 3, and cotangent is minus square root of 3. If we rotate down here, let's see, if we rotate this way in the negative direction, we're going negative 5 pi over 6, or negative 150 degrees. Or if we rotate the other direction, this is pi plus pi over 6, that's 7 pi over 6, or 180 plus 30 is 210 degrees. Okay, or any other rotation that ends you up at that place. Would have an x of negative square root of 3, y of negative 1, r of positive 2. Notice r is always positive, and notice all of these have a cosine that's either square root of 3 over 2 or negative square root of 3 over 2. Cosine is negative down here in this quadrant. Secant then is the reciprocal of that. It's either 2 over the square root of 3 or negative 2 over the square root of 3. Secant is going to be negative in this quadrant. Sine is always 1/2 or negative 1/2 for any of these particular ones where the reference angle is 30 degrees or pi over 6 radians. And so we get either negative 1/2 or positive 1/2, and down here what's going to be negative. Cosecant being the reciprocal is going to be negative 2. And all of these have a tangent of either 1 over square root of 3 or negative 1 over square root of 3. Tangent is positive down in this quadrant of quadrant 3, so it is 1 over square root of 3. Its reciprocal cotangent is square root of 3. So that concludes all the different ones. We're going to come back and kind of put all these together in a summary in our last video on this particular topic in a few minutes.